Huffman code is one of the ways to make code words close to entropy. The algorithm is as follows. In the probability distribution, two cases with lowest probability are selected and merged. In this case, DE is 1 over 16 probability 1 over, so they merge it and make 1 over 8. Continue this process until the last one is left. In this case, next case is 1 over 8 is 2 1 over 8 is the smallest probability, so they are merged and to make 1/4, and then 1/4 and 1/4 merged and to make 1/2, and 1/2 and 1/2 merged make to 1. So if it becomes one case, then we will put go backward and put 0 and 1 at each branch. Okay. As a result, the code word of A becomes 0, and code words for B becomes 1 and 0, and code words for C becomes 1 1 0, and code words for E becomes 1 1 1 1. Okay. Observing the result, if probability is high, that code word is short, and if probability is low, the code word is long. So in this case, A is highest probability, so its code word is just 1 bit, and while the code word for E, which is probability 1 over 16, is length is 4 bits. If you look closely, you can see that the length of code word is the same as amount of information. Amount of information is log 2 reciprocal of the probability. So when C is probability 1 over 8, so 1 over 8, then amount of information is 3. And then code is 1 1 0. So code length is 3. So in this case, amount of information is the same as information amount. Let's encode and decode a history of in which A, B, C, D, and E are randomly selected. Since the first one is A, then the code word is 0, and then C becomes 1 1 0 1 1 0. Next A 0, B 1 0, and C 1 1 0, A 0, D 1 1 1 0, and A 0 and B 1 0. Okay, so encoding is done by using this code book. Then the sequence of binary data is transmitted through a communication network. The receiving side should look at this sequence of binary bits and decode what was sent. When decoding, the code tree is used, code tree. It starts at the root and follow the tree according to the input data. Then when you encounter a symbol, then it stops, record it, and then go back to the root. Okay, 0. 0, and you meet symbol A. So you record A and go back to root. And then you meet 1, and you go here, and another 1. Then you go here, and 0. Then you go this side, and you meet C. So you record C. And then go back to root, and you meet 0. Okay, uh, and uh, and so on. Even though there is no delimiter in between two adjacent code words, you can decode what they sent in the receiver. This way, the history of alphabet symbols can be obtained as sent by the sending side. Here, this zero is zero that was used when you decode as B, but why it is not decoded as A? Please think about it. And length of code word in this code book is a variable, so not the same fixed size code word length. Let's analyze this code quantitatively. Five alphabet symbols appear randomly with different probability, and code word for word length is varies from 0 to 4. And however, in each case, the information amount appears equal to length of code word. In other words, the average of code word is the same as entropy. If all the code lengths must be the same, the minimum code length that can represent 5 different cases is 3-bit. So therefore, the average code length could be reduced by using this variable code word. Let's make Huffman code for the dice case. As following Huffman algorithm, you can make it like this. Merge the lowest two, and then make 1/3, and then lowest two, it becomes this one, and then you make in lowest like this. And in this case, we have they left 3 cases, and then you can combine like this, and then combine like this. So it is used to make a code word. Let's analyze this quantitatively. Code length is 2 or 3, 2 or 3, and entropy is 2.58, and average of code length is 8/3. So 1/6 multiplied by 2, 1/6 multiplied by 2, and 1/3 multiplied 3, all of them summed, then it make this one, 8/3. 8/3 is 2.666, and it is closer to entropy 2.58 than 3-bit fixed length code. It decreased a little. However, compared to our hard work, it did not decrease much. Huffman code is more effective when probabilities are concentrated in one place. Let's say there are 17 symbols. Then if you use a fixed word, a fixed length code, you should use 5-bit code words. However, if you calculate the entropy, it is 3.5. So it means you can think of 30% reduction using Huffman code. Please analyze it. What if one probability is 3 over 4 and the remaining 16s are 1 over 64 each? Please analyze this. Huffman code is not the only code. There are arithmetic codes used for video compression, and there are zip codes that use a lot. Zip code is an effective coding method for compressing document files. The most important thing you learned in this class is entropy. In information theory, coding is explained to see how entropy is specifically used. In the second law of thermodynamics, one of the important concepts in mechanical engineering, entropy is said to always increase. At this time, entropy is the same concept of entropy, our entropy. Sociologically, an increase in entropy means the society becomes democratized, more democracy. The coding scheme described using the entropy theory is used in digital communication. In a word, a digital communication system is a system that delivers binary data. The information on this side is encoded and transmitted through communication channel, and then receiving side decode the information and restore information to use. Next time, we will cover the theory of communication channel.